No, I'm not going to.
I just said, I just baptize people into this by saying the universe is under no obligation to make sense to you.
Yeah. But but we're always in a state of subtext then in some way?
Possibly.
Yeah.
There's some things we might know completely.
So he says it's like it's a fact, and then he says possibly. And basically, it doesn't make sense to him. So apparently, it can't make sense to anyone else.
Leave us high and dry at the singularity of the black hole and at the singularity of the Big Bang itself. It's like dividing by zero. You remember you're not supposed to do that in math class?
So scientists always talk about quantum fluctuations before the singularity, but that was when everything was cold energy. Now look, what comes before the singularity? The omega point is the final step before the singularity takes place. The final step before? The singularity is everything, right? The beginning of everything. The omega point is theorized a future event in which the entirety of the universe spirals toward a final point of unification. This is when everything's coming back together. This is when the big bounce is about to occur because everything's recollapsing because it's going to happen again. So technically, the omega point is the end and the beginning of everything, meaning it happens in a circle. It's a spiral, technically a downward spiral. So basically, Genesis 2 is the omega point, which is the beginning and the end of everything. You might say the energy spirit moving upon the face of the waters. This right here, along with the downward spiral, the golden ratio. And I'm just saying that the chronology of the universe here is messed up because there's no cold. Yes, everything comes from nothing, but that nothing was still, there was energy there, like the quantum fluctuations or foam that they talk about, static foam. So they don't even think or consider the laws of thermodynamics at all. They completely ignore the fact that thermodynamics actually exist. Everything just starts with hot. And what, there was no cold before that? And then Neil deGrasse Tyson said, oh, you can add as much hot as you want, but if you add as much cold, you can only get to zero, meaning there's no such thing as cold. Well, technically, you can't add cold. The only way to get cold is to remove heat. So that's a backwards way of thinking, not to mention the fact that every light has to eventually go out and everything comes from cold. And that hot had to warm up somehow. And they don't have that era. Now, the Planck epoch is that static I showed you. Grand unification here. Mass charge, flavor, and color charge were meaningless. That means they weren't even thought of. So that has to be before the quark-gluon plasma stage. So this has to be where it has to be cold somewhat. Now, the electromagnetism, there is no electromagnetism yet. It's electrostatic because there's not any uniformity of the electrons because everything came from leptons, electrons, and neutrinos. So as it's collapsing, the strong interaction is gravity, and it's all weak interaction and electronuclear force because it's collapsing. Like I explained in this video, this spatial value is decreasing and it's getting denser, meaning it's losing its buoyancy and it's coming to a focal point at its hottest, densest, which is the quark-gluon plasma. So all this is this is cold. It's gamma rays, X-rays, and UV rays. There's no photons yet. It's just dark light. This inflationary period is actually a condensary period or condensary period. Yes, it's supercooled, but it's still supercooled. It's only barely warming up. Of course, this is an electroweak epoch because there's no color charge, which is strong force. Now they have the quark epoch here, which is the quark-gluon plasma. That's correct. But since everything came from leptons, the lepton epoch down here is supposed to be up here in the Planck epoch. And when it starts to condense, that's when you have the neutrinos and the electrons condensing to form muons, and the muons condensing further to form the tau. Think of them as stages of star. Now, scientists have all of the stuff after the singularity was born existing just then, but it existed in a different form prior to the singularity. And you might call the singularity the Higgs field, because once everything moves through the Higgs field, that's when it gains its mass, color charge, and photons are created. See, neutrinos are technically light, like a photon, but they're really light. And a photon is actually heavy light. And you don't get heavy light until you move through the Higgs field, and quark-gluon plasma is made where you get actual true bright light, white light. See, they have everything starting at the middle instead of at the beginning when it was cold. Like there's none of this that exists and it just goes from here to here. But if they would move the middle to the beginning, we can get a consistency. An HR diagram is the white light itself. as a whole. All this is the light spectrum, the white light. White light is born. The universe is white light. And here they have this backwards too. They have it reversed. So it gives you kind of an inverted way of looking at it too. But all of this high gamma, they have atomic nuclei. There's too much gamma to form nuclei. It has to taper off before it can actually form nuclei because there's a lot of radiation. And temperature and radiation, even though this is very cold, it would still burn someone up because it's radioactive. It's very highly energetic, even though it's cold. It's like a microwave. Microwaves don't technically have a temperature, but they make things hot because they're a type of radiation. So there's kind of a divisible marker there that's kind of being swept under the rug also. So all of this gamma here is all that electromagnetic radiation, neutrinos and electrons, further condensing. You have muons, muon catalyzed fusion, which is this margin here. And we use muon X-ray machines too. So we can use muons to actually as an X-ray. And that's a connection there. Ultraviolet is dark light, which is UV, and black light, which is basically black light. And that's why there's a lot of UV in black lights. And they show such an odd looking spectrum. And it's actually violet. See, all of this is clear. And between the muon and the tau, where these pions emerge, it gets to a pinkish type of color before it's a violet. And it becomes blue and white. Then inflates through the light spectrum, and then progeniting a whole light spectrum of stars.
It's always happening. But the event itself, the singularity itself, do we have enough information to recreate a visual representation of that singularity?
To some degree, I would say a little bit after, the universe starts to expand. Yeah.
So we can't get the birth, but we could maybe get a slap on the ass. The baby slap on the ass we could get, but we couldn't get the actual,
Pretty much. You get that first cry out.
You get the first cry, but not the actual,
Someone asked, does cold exist? The answer is no.
Yes, it does. It's all it exists.
Because if it existed, you can get as much of it as you wanted and continue to make a temperature colder and colder and colder. But there is a lowest possible temperature where the vibration of all atomic and molecular motion is at a minimum. There's no temperature below that. We call that absolute zero. A whole brand new temperature scale was invented to accommodate this fact.